This is section 7.2, two variable linear systems. We're only going to spend 1 day on this section. So as I said before, there are 3 ways to solve systems: substitution, graphing, and elimination. We've already covered substitution and graphing. So today and in the remaining sections, we're going to talk about elimination, the method of elimination. So the method of elimination works as follows. To use the method of elimination to solve a system of 2 linear equations in x and y, perform the following steps. Now you don't necessarily need to write all these down, because once you know the method, you just do it. You don't have to follow these steps necessarily, but I'm just going to read through them, and then we'll see examples of how this works. So first you obtain coefficients for x or y that differ only in sign by multiplying all terms of one or both equations by suitably chosen constants. Alright, just a fancy way to say that sometimes you need to multiply the equations to get the right numbers. And we're going to see that specifically. Then you add the equations to eliminate one variable. That's why this is called the method of elimination, because you first eliminate one variable and solve for the other. Then step 3, you back substitute the value obtained in step 2 into either of the original equations and solve for the other variable. Step 4, check your solution both of the original equations. Again, that's just a run-through of the method of elimination. Don't worry about writing all this down, because I think it'll become clear in the next few screens. And also, you probably have seen this already in Algebra 1 or 2. Now, even though this might be a bit of a review for you, be patient, because it is necessary for the next sections, which are not going to be a review, especially when we get into systems of 3 or 4 variables. So 2 variable linear systems. These are the simplest kinds of systems, and we're going to solve these by the method of elimination. For example, we have the system 3x plus 5y equals 7, 3x plus 2y equals 1. Now, you can solve this by substitution or graphically, but elimination is easier here because, as you can see, both equations contain the term 3x. So we can get rid of that term. How do we do that? We subtract. We're going to subtract the second equation from the first equation. And we end up with 3y equals 6. And then it's very easy to see that y equals 2. And then we back substitute. We back substitute the y equals 2 into either one of the equations in this system. And when we do that, we can solve for x, and we get x equals -1. Alright, so we've solved this system. We found that our ordered pair that satisfies the system is -1, 2. X equals -1, y equals 2. And we found that solution by using the method of elimination. Here's another example. 2x minus 3y equals -7. 3x plus y equals -5. Now here, the first thing we do before we proceed to eliminate a variable is we multiply the second equation by 3 on both sides. And that's to get the y terms to match. So we'll end up with this as our new system. 2x minus 3y equals -7. 9x plus 3y equals -15. And now we simply add the equations. And when we add the equations, we eliminate the y term, and we get 11x equals negative 22. Solving for x equals negative 2. Back substituting, we plug that negative 2 in for x. We're going to use the first equation, and we end up with y equals 1. So once again, we have solved this system. We found that the ordered pair that satisfies it is negative 2, 1, x equals negative 2, y equals 1. And we found it using the method of elimination. Here are a couple more examples. The first example, 2x minus 4y equals 14. 5x plus 3y equals 9. Alright, so you should know enough by now to solve this on your own. You should pause the video, do it on your own, and then resume when you have an answer. So the first step you should have followed is multiply both sides of the first equation by 3. And multiply both sides of the second equation by 4. And you do that because you want one of the terms to be identical. And this will make our y terms identical, differing only in sign. So I end up with 6x minus 12y equals 42. 20x plus 12y equals 36. Now, to eliminate that y, we simply add the two equations. End up with 26x equals 78. X equals 3. Back substitute. And I find that y equals negative 2, so my solution is 3, negative 2. Alright, so you should have gotten that answer on your own. Here's another example. 0.02x minus 0.05y equals negative 0.38. 0.03x plus 0.04y equals 1.04. Now, you probably thought of this on your own, but just to give you a hint, you're going to want to get rid of those decimals first, and I'm sure you know how to do that. So pause the video, do this entire problem on your own, and resume when you have an answer for x and y. So the first step, multiply both sides of each equation by 100. That gets rid of our decimal place, our decimal point, and so we end up with simply this system, 2x minus 5y equals negative 38. 3x plus 4y equals 104. Then what we are going to do is multiply the first equation by 3 and the second equation by 2 to get our x terms identical, and we end up with 6x minus 15y equals negative 114. 6x plus 8y equals 208. Now we can eliminate the x term by subtracting the second equation from the first. And we end up with negative 23y equals negative 322. Y equals 14. Back substitute into any equation. This is a simple one, 2x minus 5y equals negative 38. We plug 14 in for y there, and we solve and get x equals 16. So the solution to this system is the ordered pair 16, 14. And once again, you should have been able to get that on your own. Continuing now with linear systems, x minus 2y equals 3, negative 2x plus 4y equals 1. Pause the video, try to get an answer for this, and then resume. But don't spend too long on it if you get stuck. So if we multiply the first equation by negative 2, we end up with negative 2x plus 4y equals negative 6, and negative 2x plus 4y equals 1. And then when we try to proceed with our method of elimination, and we subtract the second equation from the first, we're going to end up with this ridiculous statement, 0 equals negative 7. Well, that's obviously impossible, and therefore this linear system has no solution. No solution. Let's look at this linear system, 2x minus y equals 1, 4x minus 2y equals 2. Once again, pause the video, try to do this on your own. Don't spend too long on it, and resume when you have an answer, or at least have made an attempt. So if we multiply that first equation by 2, we end up with 4x minus 2y equals 2, and 4x minus 2y equals 2. These are identical. And if we try to proceed with our method of elimination, we get 0 equals 0. Well, that's always true. And when you end up with something that's always true, then the system has infinitely many solutions. Infinitely many solutions. Because this system will work with any x that you plug in. All you need to do is just adjust the y accordingly. So it has infinitely many solutions. So to kind of review these two cases, if you end up with an impossible statement, then there's no solution. If you end up with a statement that's always true, then there are infinitely many solutions. So continuing with linear systems, an airplane flies into a headwind and travels 2,000 miles from Chicago to LA. The trip there takes 4 hours and 24 minutes. The trip back takes 4 hours. Find the speed of the plane and the wind. Alright, so this is a good practice problem for you. You should pause the video, try to set it up on your own. If you get stuck at a certain point, you can resume until that point that you were stuck on, and then try to pause again. Keep working through it on your own until you end up with an answer. So these are the equations. 2,000 equals a minus w times 4.4. 2,000 equals a plus w times 4. All right, where did we get that? Well, the 2,000 is because 2,000 miles. This is for the trip going there in which the wind is against you. You're flying into a headwind. That means the wind is against you. That's why we have a minus w. A is the speed of the plane. W is the speed of the wind. And the wind's going against the plane, so it's a minus w. 4.4, where does that come from? Well, 4 hours and 24 minutes is 4 hours and 4/10 of an hour, because 24 minutes is 4/10 of an hour, so 4.4. The other equation, 2,000, because the distance is still 2,000 miles. This is for the return trip, and on the return trip, you're going with the wind, so it's a, the speed of the plane, plus w, the speed of the wind. 2,000 equals a plus w times 4 hours. All right, so this is our system, and now we can work with this. 2000 equals 4.4a minus 4.4w. 2000 equals 4a plus 4w. All I did there was multiply it out. Then 2000 equals 4.4a minus 4.4w. 2200 equals 4.4a plus 4.4w. All I did to the second equation is multiplied each side by 1.1. And that's why I ended up with 2200, because that's 2000 times 1.1. And 4.4a is 4a times 1.1. And 4.4w is 4w times 1.1. So I've got this system now. And then I can see that this is easily solvable by elimination. I add the equations together and I get 4200 equals 8.8a. A equals 477.27. Then I back substitute, put that a in either one of those equations there. 2000 equals 4a plus 4w is a little simpler, that's why I used it. And we then solve for w and find that w equals 22.73. So the final answer then to this word problem is 477.27 miles per hour. That is the plane speed. 22.73 miles per hour is the wind speed. Here's the classwork, page 515. Please copy these numbers down. Get a head start if you want.